The Newton-RAPHSON method, named after Sir Isaac Newton and Joseph Raphson, is a powerful root-finding algorithm that leverages the principles of calculus to approximate the roots of a real-valued function. This method employs an iterative process guided by this formula. This formula, derived from the Taylor series expansion, represents the heart of the Newton-RAPHSON method.
Let's consider a quadratic equation as an example. X squared minus 10x plus 25 equal to 0. We'll use our calculator to find its roots using the Newton-RAPHSON method. First, in the setup section, we put 2 as the power of our function, indicating it's a quadratic equation. We also provide an initial guess for the root and a tolerance value. Next, in the coefficient section, we put the coefficients of the equation. For our equation, a is equal to 1, b is equal to minus 10, and c is equal to 25. Once the coefficients are entered, the calculator displays the equation and its derivative in the equation section.
The calculator then instantly performs the Newton-RAPHSON method and displays each iteration in the calculation section. We can observe how the root approximation improves with each iteration. The result section displays whether a root has been found, indicated by true or false, and the approximate root value. This root value is an approximation of the actual root of the equation calculated using the Newton-RAPHSON method. If there is an error in the inputs or the calculation, an error message will be displayed in the error message section. This helps users to identify the source of the error and correct their inputs.
Next is the advantages of Newton-RAPHSON method. One of the fastest method which converge to root quickly. Second, converges on the root quadratically. For example, the rate of convergence is 2. Third, it makes this method useful to get precise results for a root. And the last one is easy to convert to multiple dimensions.
For the disadvantages, you may encounter a zero derivative when using the Newton-RAPHSON method. It may be also too far from the local root, as well as it has poor global convergence properties. Not to mention, you must find the derivative when using this method as well. Despite this, the Newton-RAPHSON method is widely used due to its simplicity and speed. Our calculator makes it easy to find roots of quadratic, cubic, and quartic equations.